So we're going to do a couple more examples about placing shapes on a coordinate grid. And so the first one we're going to do is a rhombus. So understand that a rhombus is actually a little bit more constrictive than what a parallelogram was, because if we try to put it at 0, 0, the really hard thing is whatever we make this length, we have to make this length the exact same. So if we were to do 0, 0 and 2a comma 0, then we'd have to find this point so that it is also, that length is 2a. And it turns out that is very difficult to do and requires Pythagorean theorem and some other things. And so that's not a good way to do a rhombus. Instead, what we want to do is take advantage of one of our properties of a rhombus, and that is that in a rhombus, you got two things that are happening. With the diagonals, you know that the diagonals bisect each other because it's a parallelogram, and which means this is the same as this, and they meet at right angles. And so what we're going to do in a rhombus is we're going to let the origin be the point where these two diagonals intersect each other, because it meets at right angles, so those right angles can be the x and the y axis. So what we do is we just draw the rhombus, and the rhombus is going to look like this. And then the other thing we can do is we can say, well, wait a second, we know that those two lengths are going to be the same and these two lengths are going to be the same. So it's actually very easy to find our coordinates. A here would be a comma 0, or you could do 2a comma 0. B would be 0 comma b. C would be, well, we went a that direction, so it would be negative a comma 0. And then D is going to be 0 comma negative b. And so a rhombus is way easier for us to do a rhombus on a putting the intersection of the diagonals at the origin 0, 0, so that we can then easily find those other points and take advantage of those right angles that are in the diagonals of a rhombus, just like we did with a kite. All right, for a trapezoid is a lot like a parallelogram in that we don't know a ton about it. And so if we draw our trapezoid on here like this, we can start by saying this one is going to be a, so 0 comma 0. And then if we want to let this point be 2a comma 0, that's great. And so if we do that, what we recognize is we don't really know anything about this triangle. These two triangles that are kind of here on the ends, they don't have anything in common. So the x-coordinate of this is not going to be connected to this 2a at all. And so for a trapezoid, we just have to do 2b comma 2c as that third point. Now the fourth point is going to, we do know a little bit about it in that we know that its y coordinate for this fourth point is going to be the same as it was for C, because the property of a trapezoid that matters is that the opposite sides or the bases are parallel to each other. So that means their heights would be the same if the one base is on the x-axis. And so we don't know where it is in the x-coordinate, but we do know in the y-coordinate. And so it would be 2d. We'd have to introduce a new variable for the x-coordinate, but we know that the y-coordinate is 2c because it's going to be the same as point C. So that's good. When you look at the last one we're going to do here is an isosceles trapezoid, and there's actually two ways you can do an isosceles trapezoid. The one way is just like we did the regular trapezoid, except this time we do know that these two triangles in an isosceles trapezoid are the same, and so we can take advantage of that to get ourselves with one less variable. And so again, we started off the same ways. A is 0, 0. B is going to be 2a comma 0. And then C, and we could either designate this distance to be 2c. If we did that, then the x-coordinate here would be 2a, the entire length from A to B, minus whatever this length is, which is 2c. And then our, because we let that be C, then our height would be 2b. And so basically this length would be 2b. So to find the last one, well, since this length right here was 2c, this length would be 2c. And so our x coordinate on that one would be 2c. And then our height remains the same, which would be 2b. The other way you could have done this is you could have let this be the 2c. And then this distance here would be 2a minus 2c. That would work as well. But either one of these work as your coordinates of the vertices of a isosceles trapezoid. And again, it's easier because we know that this is equal to this. And so we just create congruent right triangles to find those points. The other way you could do an isosceles trapezoid is you could use symmetry. It does have symmetry because of the fact that it's isosceles. And so all you would need to do, so a lot of people like this one better. It just doesn't use the origin, but if you do this point would be 2b comma 2c. Well, this distance is 2b, so this distance is going to be 2b. So this would be negative 2b comma 2c. And then this distance is 2a. So that means this distance would be 2a. So this would be negative 2a comma 0. So that works as well for an isosceles trapezoid. Either one of those is fine when you're trying to prove something involving isosceles trapezoid. So it's very important on these that you really understand how to get each of these shapes on a coordinate grid. I would encourage you to go back and practice this. Take a day or two away from it and sit down and say, okay, can I put a rectangle on a coordinate grid? Can I put an isosceles? And just quiz yourself to see what those variables would need to be to put the vertices on a coordinate grid.